My name's Jared Williams. I'm a senior civil engineering student here.
I'm a senior in civil engineering. And Alex Slater, I'm a senior.
Today we're going to talk about accelerated bridge construction, ABC. If you saw the title, what is ABC? ABC stands for Accelerated Bridge Construction. It's actually bridge construction using design and construction methods that decrease the on-site construction time and for putting up new bridges or rehabilitating new bridges or pre-existing bridges. Also, it changes project management or delivery time. So there's a lot of mobility that goes on here. And since this becomes a priority, construction managers on site need to find a way how to get this up quickly. Accelerated bridge construction includes innovative planning, design, materials, and construction methods. A lot of businesses, a lot of engineering firms use ABC as one of their techniques for building bridges because it really is cost effective. Companies like H&D use it, firms and McDonald's uses it because they figured out that it saves them money in the long run. When using ABC, it's important to know the improvements. There's site constructability, total project delivery time, and work zone safety for the traveling public. Also, for the reduces, there is reduce in traffic impact, on-site construction time, and weather-related delays. Also, one of the cool things about ABC is that when you have an unexpected bridge collapse, you can use it for that technique, and it really doesn't take that long. Also, it's hard to read it, but you can also use it for plan replacement. So if you know you have an inefficient bridge, you can also use that technique for it. One of the reasons, and one of the good things about living in the U.S. is that we have a lot of infrastructure already built. So ABC is just a short portion, just usually it's a bridge. It doesn't have to be that big. So since most of our infrastructure is already built up, we can usually just cut out a slice and just replace it. Lastly, there's some time metrics. There's on-site construction time, which is the time at the start of the project to the end. And there's also mobility impact time, which is the impact time for you and I, just passengers that are affected by this. So, and they're broken up by categories, tier 1 all the way down to tier 5. So we did have a video, but actually it's probably going to go over our time. So I'm just going to talk about methods.
There's lots of different methods for ABC. One of the main uses in ABC is prefabricated bridge elements and systems, or PBES. Those are the bridge structure elements. The elements include the beam, the deck, the piers, abutment walls. And you can also do the system where you have the entire bridge superstructure or substructure, or you could just have the entire bridge for smaller bridges. One of the big issues is that it's really hard to move those PBESs, and there's lots of different techniques that you can use for movement. One being the self-propelled modular transport, or SPMTs, skidding or lateral sliding, longitudinal launching, and float-ins. SPMTs are very large multi-axle platforms. They are computer-driven that can move up to 360 degrees, and they move at a walking speed. They are used to lift, carry, and set the entire bridge structure. Skid and lateral slides, they're used for bridges that are built right next to the existing bridge, so they can keep that existing bridge open while they're building the new one, and then just slide it into place once they remove the existing bridge. And that's basically what that video was showing, was how they built this and slid the old one out and then slid the new one in and reduced a lot of time. They use pulling cranes to pull that in, so it's a lot easier than building a bridge right there without closing the road. Another thing is longitudinal launching. They use the SPMTs to move them up close to the edge of the abutment, and then just place the bridge across the span that way. They also use incremental launching methods, and those are for large multi-span bridges, which are usually used in deep valleys, deep water areas, or environmental protected areas. An example of that would be Highway 20 that goes over the Iowa River in Hardin County. And you can see that here in this picture, how they just go from one span to the next. And that's a faster way of building those types of bridges. Float-ins are really basically the same thing as lateral slide-ins, only they're over water, so obviously you're going to have to float the bridge in. And here you can see how they have a bridge system here, using barges to place it into place. They can also use demolition methods to increase or decrease the time of construction. They use conventional ways such as using excavators that have jackhammer attachments, or they use cranes that have wrecking balls and they just lift out the entire bridge for smaller bridges. They also use SPMTs and the lateral sliding, where they can just detach the existing bridge and slide it out of place or move it out of place with the SPMT. Ryan's going to talk about the benefits of ABC.
Okay, so one of the main benefits is actually the first word, it's accelerated. So you don't need to spend as much time closing down a bridge, demolishing it, setting it up piece by piece, pouring, everything's accelerated. So you need less detours, reduces traffic disruption. You don't need to spend time, you don't need to see that bridge closed sign for very long. You can almost do this in a weekend, depending on the size of the bridge. Temporary structures are not needed anymore. They can be, you put them up fast just to try and supplement the construction process, and sometimes they're not as stable. And so getting rid of all of that is very beneficial for the building process. Workplace safety is increased. Less time spending building the bridge. If you're over high waters or a valley, workers have an increased workplace mishaps, falling off the bridge and so forth. So you have less time with that. Workers have less interaction with traffic. If you close the bridge down at night, less traffic, get it demolished, and then slide the new piece in, have it done. And costs are reduced. You don't need to have the temporary structures. You don't need post-construction repairs, which is due to detours going along roads that aren't meant to handle high traffic levels that involve construction. Side roads that just can't handle all the construction repair. And they're all the detours are either reduced or even eliminated. So anytime workers don't need to be on the job site as long, you don't need to pay them as much, or pay them for the time working. Rental fees due to construction are severely reduced. Some disadvantages are precast members can be very bulky, and they can also be hard to get to the job site. If you have a whole bridge span traveling down the road, that's going to cause traffic, that's going to place a lot of load on the roads, and that can reduce, or that can cause more problems. It's a relatively new process, so it's still being proven whether it's effective or not. So still working out the kinks. And with the prefabricated method, there's a lot of joints that go along with it, and more joints introduces more chance for water damage within the joints. So freeze thaw can be a problem with that. And sometimes it can, since it is a newer process, they're still working out reducing costs, but in the long run, it reduces the overall project time, which is saving money in the long run. There's many bridge projects in Iowa right now. The current one is the US 6 bridge over Keg Creek. So we're still testing it. It's in their experimental construction site on the Iowa Department of Transportation. So we're still testing it, still seeing how it compares to a normal construction method. Is there any questions?
Thank you.
Oh, okay.